Hello all. In today's session, we'll talk about the second topic of Unit 1, Computer Vision Pipeline Process. So in the last session, we have discussed the definition of computer vision as well as listed out few of its applications. So today we'll talk about computer vision pipeline process. To analyze and process the image data, computer vision follows few steps. Those steps are called as pipeline process. We have talked about the two main components of vision system. One is sensing device and the other is interpreting device. In sensing device, we make use of camera to capture the image. This captured image is to be interpreted. So we make use of interpreting device where few neural network algorithms or convolutional neural network algorithms are used. To make use of these algorithms, these interpreting device need to follow few steps called as computer vision pipeline. In the first step, we'll have input data, which is nothing but image data or videos. Here we'll talk about images only. In the second step, we pre-process the captured image, which is nothing but we standardize the image as per our requirement. Third step involves the extraction of features, that is extraction of information about the image which is captured. And the fourth step which is involved in the pipeline process is the captured image or the extracted image will be given as input to this model, which will make predictions based on the extracted information. Let us apply the pipeline process what we have discussed previously with this image classification task, where our task is to predict the probability of the object from the following classes of motorcycle, car and dog. Given an image, I would like machine to find the probability of that image belonging to motorcycle, probability of that image belonging to car and probability of that image belonging to dog. Higher the probability, under that label that image will be predicted. So the first is input data. Second step involved is pre-processing, where I'll standardize the image. I'll either go for geometric transformation or image blurring and so on, where uniformity is maintained. Next, after pre-processing, I'll go for the third step, that is feature extraction. I'll extract the information of the image which is captured. You can see here, I have wheels extracted, I have seat, front light and also mud guards. All these are the features which are extracted from the image, pre-processed image. Based on these extracted features, I will classify it to be as a motorcycle, car or dog. That is, I will find the probability of predefined labels, and the probability here for motorcycle is more compared to that of car and dog. Hence, this given image is labeled under motorcycle. So one by one steps we'll look into. The first step is input data, which is nothing but image. So here images are of two types. We'll talk about grayscale images as well as colored images, which are nothing but RGB, red, green and blue images. Image can be represented as a function of two variables x and y in a two-dimensional area. And a digital image is made up of grids or pixel values. These are the grids for image data, and each box represents pixel value, and that pixel value is nothing but the intensity of that particular image. Grayscale images are either scalar and binary. Scalar images integer value ranges between 0 to 255. For black and white images, my range is 0 to 255. You can look into the image here. This is the original black and white image. And when I have only 8 colors selected for A is equal to 3. And this image represents for A is equal to 2, that is 0 to 3. So grayscale value ranges between 0 to 255 with 256 values of pixels. So 0 represents black and 255 represents white colored image. You can look into this image given on the slide here. It is a grayscale image of 32 by 16, that is 32 rows and 16 columns. At this point, I am representing image as f of x comma y, where at x is equal to 12 and y is equal to 13, the intensity of that given image is 255, which is a white colored image. Looking this example in this box, at x is equal to 20 and y is equal to 7, the intensity value is 0, which represents black colored image. So the minimum value is 0, which represents black image. Maximum value is 255, which represents white colored image. And here you can see a gray image here, whose intensity ranges between 0 to 255, which is 190 at x is equal to 18 and y is equal to 9. So it is a two-dimensional representation. Grayscale images are represented in two dimension x comma y with intensity values ranging between 0 to 255. 0 represents black and 255 represents white. I can have image transformation also for the given image, the previous image only. You can say that if I would like to darken my image, that is reduce the intensity, I will multiply f of x comma y with 0.5. That is, if I multiply 255 with 0.5, intensity reduces, thereby the image gets darkened. To brighten the image, I will multiply it with 2. So if I multiply 190 with 2, the intensity increases, thereby image gets brightened. And if I would like to move the object down to 150, that is along y-axis, I will write x comma y plus 150. If I would like to move the object right side along the x-axis, I write x plus 150 comma y. And if I would like to convert the image into black and white, g of x comma y is equal to 0 if the pixel value is less than 130, and if pixel value is greater than 130, I will equate g of x comma y is equal to 255. Coming to the colored images will be represented as three numbers R, G and B. That is the intensity of red, intensity of green and intensity of blue. Colored images has three channels, that is RGB, whereas grayscale images have only one channel. Color images is having three matrices stacked on top of each other. That's why it is a 3D matrix in this way. Each channel for R, G and B respectively. How do computers see a image? This is the image what we see, whereas this is the image what a computer sees. You can have a grid representation of some numerical values, and those numerical values are nothing but the pixel values or intensities of the given images. This is the colored image. You can see here I have three dimensions, one for R, one for G and one for B. These are the three channels. First channel, second channel and third channel. For example, I am concentrating only in this part of my image. This part, intensity value of R is 11, intensity value of green is 102 and intensity of blue is 35. Combination of 11, 102 and 35 will result in a forest green color, which is this color. So you can see below here, forest green is formed by the combination of intensity of RGB, and this is the hex code for that particular color. This is the hex code of olive, and which is formed with these three intensities and so on. Coming to the next step called as pre-processing. In pre-processing, what do? Is we standardize the image. That is, this method is used to ensure that uniformity in size and resolution is maintained for further processing. Image must be pre-processed and scaled to have identical width and height before we feed that image to learning algorithm. So these are different pre-processing techniques used: grayscale conversion, normalization, data augmentation and image standardization. These are the few pre-processing steps used by a computer vision to have pre-processing of the given image. This is the end of today's session. In the next session, we'll start with these pre-processing techniques. Thank you.